Welcome to this poster presentation. My name is Tim Wilke and I will guide you the next minutes through the poster with the title of Science in the Spotlight, Didactic Reconstruction of Current Research for Chemistry Education. As for a short introduction, we like to point out that a good communication between science and society is of a very high relevance and interest to both these groups. Currently, the subject of chemistry is unfortunately often perceived by students as very abstract, lifeless, and over 70% of the students cannot imagine taking up a STEM profession. The examination or the implementation of current research within exciting context and with a high level of relevance to everyday life offers a high didactic potential to address this challenge. Future-oriented topics and their associated research methods can be made accessible to school chemistry education through the didactic reconstruction, which we're going to show you later on. This offers students, as well as teachers, not only motivating learning opportunities and contexts, but also enables participation in social discourses in the sense of a scientific literacy and reveals new career perspectives for the students. It offers the interested public the opportunity to encounter future technologies and to obtain comprehensible first-hand information and to participate in scientific and educational policy debates. One of those future-oriented research topics is photochemistry with a high didactic potential. Reactions driven by solar light are also the main focus of the German collaborative research center CATALIGHT, which is hosted by Ulm University and Friedrich Schiller University in Jena. To pave way for a broad usage of abundant solar energy, CATALIGHT develops molecular light-driven chromophores and catalysts and establishes concepts for their integration into soft matter matrices. This thematic orientation offers excellent opportunities for school chemistry education. Since chemical reactions with solar light represent the basis of numerous processes of life in the biosphere, they also have broad applications in everyday life, science, and technology, ranging from photocatalytic wastewater treatment to light-emitting diodes, LEDs, and beyond. Due to this great importance in the present and in the future especially, and because of the possibilities for interdisciplinary considerations, they offer as much potential for teaching in formal as in non-formal educational programs such as school laboratories. But for successful transfer from the CATALIGHT research and research results and methods into school chemistry education and student laboratories, there are many challenges yet to be addressed. I'd like to show you the two main challenges in the next two slides. The first challenge lies in the topic and the complexity itself. Due to its very high specialization, fundamental research is usually very demanding and also very difficult for learners to comprehend. Especially for the understanding of light, there are inaccurate preconceptions or misconceptions on the part of the learners which have to be addressed. For the research process, the model of didactic transfer research is used as a foundation for this process, which opens a structuring framework for the scientific development of the contents. The figure down below there visualizes the three main sections, which include, first, the didactic reconstruction of the contents, which we are doing in cooperation with scientists. Secondly, the development of teaching materials in a cyclical process of conception, testing, evaluation, and thus optimization. And third, the final dissemination of the tested materials into science and teaching practice. The second challenge is that we need analytical methods in schools in order to perform simple experiments there. To provide these tools, we use the digital measurement station LabPi in our project. LabPi is an open platform which we developed, on which a multitude of measuring variables can be easily recorded. This is achieved by combining single-board computers, you see it at Raspberry Pi down below there, with miniature sensors, which are also shown in figure number 3. With an adapter board and the corresponding software, which we both developed, simple measurements of pH value, temperature, conductivity, as well as very important photometric investigations are possible. Altogether, LabPi provides the low-cost and robust analytical methods we need in chemistry teaching. Altogether, we think that the subject area of photochemistry offers excellent learning opportunities for school chemistry education and even more everyday life connections. We think that in school, the challenges of society as a whole can be discussed within the framework of this context, especially when we think of hydrogen generation for future mobility. The research work in the CRC CATALIGHT offer an ideal environment for this, in our opinion, and within the next years we will didactically reconstruct several contexts within these frameworks for school and for student laboratories. Below, I have shown you the references, and with this, thank you very much for your attention. Bye bye, and see you next time.